something like that. A V-shaped graph, absolute value. V-shaped. Now, that's what we know right now. And we know the notation. I'll put an X inside. If I see those two straight bars are asking me to take the absolute value of X, I think every kid in that middle school across the street would know how to find absolute values. We know how to find absolute values. So why on earth are they doing this in a pre-calc textbook? When I know, professor, I know before we get into the lesson, I know if you do this, professor, the answer is this. I know if you do this, the answer is this. I know if you do this, I know it's this. Are those statements correct? Do those middle school students do that? So all we're thinking of right now is the absolute value. In my mind, professor, means positive, positive, positive. I could throw this in. The absolute value of 0 itself is 0. So that's the exception. 0 is not positive. But the answer is going to have to be positive. By the way, is this graph that represents absolute value, is it above the x-axis always? Except at 0. So is this a good illustration of what absolute value of each shape graph should look like? It's above the x-axis, which indicates it should be positive. And we know the answer should be positive. No problem there. So what's going to make this section so hard, Professor? It's not. It's not hard. Now, based on this graph, though, on the side here, I notice that I think there's like a definition on that handout. And you guys can remind me. I think they use a U inside, the absolute value of U. I gotta see if I'm correct. Do they say absolute value of U is equal to U? Is that the way they have represented on this handout or not? Do they use a U there, absolute value of U, or not? What's X? A is the name. Okay. So absolute value of A, they're saying is A. Did they say anything else? Oh, I guess I can look at the handout myself. Let's see.
Absolute value of U equals A.
Yeah, now I've got the U here.
So it's that U equals
Yeah, absolute value of U is equal to A. That's what I'm looking for. The absolute value of U is equal to A. And I see on the side here it says it's equivalent to or means U is equal to A, or U is equal to a negative A. So when I open up a textbook and I see that, they're not telling me anything new. I know what that means. Now if I say, okay, professor, what does it mean here? Right here it is. Absolute value of X is equal to 5 means, if I follow this definition, that what, guys? X is equal to 5, or X is equal to what? Negative 5. That's all they're saying. We all knew that, but they had the statement written in your textbook. We knew that. Now, I did, though, to do something else with this, I did make it a little bit more interesting with this definition. There's on the handout here, I have something like this. Absolute value of 3x minus 1 is equal to 2. Now, what does that mean? If I use that basic definition at the top there, it means 3x minus 1 is equal to 2, or 3x minus 1 is equal to negative 2. Same thing. That's the definition. And I could easily solve these right quickly. Guys, we can do it quickly. X is equal to 1, or over here, X is equal to, looks like it might be a negative 1/3. I did it quickly. Someone check me. Is it negative 1/3? So there's my solution. Is it, guys? I did it quickly. Number 3. 1, 2, 3 here. If I follow that basic definition, I think I threw in just a couple more of these. I did. Absolute value of, here we go, guys. I'm going to pick up this one next. X squared plus X is equal to 12. Well, if I follow the rule here, the definition, it means X squared plus X equals 12, or x squared plus x is equal to a negative 12. And then you're going to solve each one of those. That's all it means, by definition. The first one, guys, to solve the first one, which will require a little bit more work here. Let's move that 12 over, subtract it, x squared plus x subtract 12, and now we're back into a nice little quadratic. It may factor, it looks like it does factor, x plus 4, x minus 3, equals 0. Split this up, I did it real quickly. It looks like x is a negative 4, x is equal to 3. I did it real quickly. If I do the other option, down here by definition, move the 12 over, I can make this one look like this. X squared plus x plus 12 is equal to 0. This one will not factor, so I may want to turn to a quadratic formula. If I do, I'm going to end up with x is equal to negative 1 plus minus. Guys, underneath that square root, I'm going to put all the numbers in for you. I think I see 1 subtract 48, which is like negative 47. All over 2. Now, what's the issue on that? Yeah, now we're into imaginary numbers, and we're looking for real numbers here. So guys, I'm going to leave that part out and say the best I can do here for solutions would be to accept the negative 4, positive 3 to satisfy that equation. You can't go wrong on this. You cannot go wrong on this. Now, if they do open up and say also consider complex, I may go ahead and finish this thing up and see what I can do with it. But right now, they're looking for real zeros, real numbers here. No problem. There's no problem there. Now, let me see if I added anything else to this. Oh, I did. One more here. Number 4 is called. Number 4 looks like this. Absolute value of 2 subtract x is equal to a negative 4. Now, guys, can you use this definition and tell me what this means? Anyone? Okay, now that's the response I want to hear. This one's impossible. Vernon says, don't even try, Professor. Don't try to apply this rule here. This definition, not on this one, Professor. What's the problem? Well, it's a little common sense problem. She says, leave it. D and E does not exist. No solution. Vernon, you want to tell the class why you said don't even mess with it? Yeah, you can't do an absolute value and get the result to be a negative. That's impossible. So if you do an absolute value and get the result, the outcome there, it's going to be a positive. So that's impossible. Can't even deal with it. And guys, I did see one more there that you guys could try to work yourself. But it comes down to just this basic definition. You cannot go wrong on one of these. Solve an absolute value equation. If I use that definition, those two cases there. Where you could go wrong, though, is the next part. The next part says, now consider, guys, I'm going to do something here. Absolute value u is less than a. I want to go back to my sketch. I'm going to point out something here. That's done. I don't want to confuse you on the side here. Now, suppose it said this. Absolute value x is not equal to 2, is less than 2. Now, some of us could sit there and think, okay, I can think of the numbers when you plug those in or substitute x with those numbers, Professor. Take the absolute value, the result will be less than 2. I will find all of them and express my answer in integral notation. So now we're into an inequality. My illustration here, guys, I've got my absolute value graph staring at me, the V-shaped graph. Now, let me place that 2 on the graph. Just say, Professor, what are you going to do with the 2? I'm going to go up to 2. This illustration. And I'm going to just draw a straight line, horizontal line, across. Something like this. So I got the blue V-shaped graph and the red horizontal line represent up at 2, and I have a couple of intersection points. Anyone tell me what might be the coordinates of these two intersection points on my illustration? I'm up at 2, and I got the V-shaped graph. So what might be the X and Y coordinates, intersection points of the red with the blue? They intersect where? Does anyone have the coordinates, the X and Y coordinates for the intersection points? Might this be labeled as, what do you think, help me out? Is it 2, 2? Is that all we're saying? This one can be labeled as -2, 2. Those are my intersection points of the V-shaped graph and my horizontal line up at 2. Now, can someone be clever, and I mean clever, tell me, I want the answer for this based on you looking at this graph. Can you read the graph for me? Translated, you want to know where is that blue graph, that's absolute value, where is my blue graph below the red? Put this in red. Where's my blue graph below the red? So if I shade in, just translate there, the blue graph is below the red, the blue is below the red here. See if you guys agree. Is this the portion where it's below? Is that true? Now, can anyone describe for me when is that happening? And that will be the solution to this problem. So the absolute value of X, the blue, is below the 2 in what interval? Anyone, from where to where is that happening? -2, out to what? +2. And there's the answer. If I ask you now, where is this happening? The blue, the V-shaped graph, let's change it to greater than 2. And I want the answer based on just the graph itself. So guys, if you stare at the graph there, and say, wait, Professor, you're asking me now, when is the blue graph above the red? Right here, the blue graph is going to be above the red here. And it's also going to be above the red here. Now be careful. Anyone tell me, when does that happen? And tell in interval notation. And that will be the solution to this absolute value inequality. The blue is above the red. And that means above the red here. That's above the red here. Be careful, when is that happening in interval notation?
-infinity.
I heard -infinity over to what?
-2.
Thank you.
Close. Union.
Union
2.
2 to infinity. That's true. Just based on the graph itself. You know, look at the graph, when is it below, when is it above, and observations, then I got the answers. Now though, I cannot, you cannot, for problems coming up in this section, when they ask you to solve one of these inequalities, you can't sketch each one, it's time consuming. You don't have the time to sketch each one of these problems and try to find the answer. So there must be some rules to follow that come from this. And I noticed on the handout, they gave, in the textbook, a conclusion of what we're doing here. Beautiful, written like this. Conclusion, let's put it in green here. The absolute value of, they call it U, is, in this case, less than A. They're saying it's equivalent to, I'll do it like this. This, A must fall between, or U must fall between negative A and positive A. Guys, please tell me. On my illustration, I have a less than right here. This is less than. I had a less than an example here. Please tell me, we found the answer up here to fall between -2 and +2. Is that same thing as -2 less than x less than 2? are these two statements, the green and the blue up here, saying the same thing? Are we saying the same thing? And they wrote it like this. That's an outcome of that sketch there. The other part, I noticed the textbook wrote this like this, without a sketch. They should have shown a sketch and shown you guys how they got this. Next one was, they're saying if the absolute value of u is greater than a, it's equivalent to, and this one's a little bit tougher, it's equivalent to this. U is less than negative a, or u is greater than a. Now, the one I did with the greater than was here. I didn't have one with a greater than symbol. They're saying now if you see a greater than symbol with an absolute value, follow this rule. It says u is less than negative a. Guys, I got this right here to be look like this. Please tell me, is negative infinity up to a negative 2 actually saying this? X is less than negative 2. Are these two saying the same thing? Is that what they're saying here? And here, 2 through infinity says, illustrate here, is x is greater than 2 in my example. That's what they're saying there. Same thing. So rather than sketching this each time to see where's the graph above, below, and all that business like I did, which I think helps for an illustration to see what's going on, it comes out to be these two rules to follow. And you're done. You're finished. Now, with all that said, illustration and the two rules to follow, then I have some examples to look at. I wanted some nice ones here. Yeah, I did. First, how do you do this? On letter A, it says solve this inequality. And it looks like this. Absolute value of 2x plus 5 is less than 7. Solve that problem for me. I'm not going to sketch it. I'm not going to sketch. I'm going to throw all the sketching. I'm going to go through the rules here. Guys, I have only 2 rules here. If I take a look at the green, which rule would this one, I see a less than symbol, I'm assuming I'm going to use this rule here in my first example, which says, right, like this. Now, can anyone read this for me and tell me what would that mean for me to write over here? Drop the absolute value symbol there, the 2 straight bars. Tell me what does that mean, real quickly, with the bars gone, as that. They're saying it means this. You're caught between negative a and a positive a. Anyone tell me what that would look like here? In no time?
-7.
Negative 7.
It's less than 2x plus 5.
Beautiful.
It's less than 7.
Beautiful. Absolute value bars are gone. Negative solid. And they want to solve for x, which you can do, easily solve it for x. It's combined, you can still do it. Let's subtract 5. Clever, from all 3 parts. Guys, if I do that, I'm going to end up with like a negative 12. Less than 5's canceled, 2x. Less than 2. And then if they want x, which we do want, divide everything by 2, think of it as a positive 2. So you end up with negative 6. Less than x, less than 1, if I have no mistake. And watch out for mistakes I can make here. Are we okay? There's the answer. If I say now put the answer in interval notation, you say, oh, problem, no problem, Professor. This means this. Negative 6 up to 1. You're done. Now, Michael, that tells me if I get outside this interval, replace x by some number outside, it shouldn't work. So I'm going to try a number outside. There's lots of numbers outside my answer here. We think the answer is this. Let's try 2. 2 is not in my answer. It's not in that interval. Shouldn't work then. If I go back and put a 2 in, 2 times 2 is 4. 4 plus 5 is what, 9? Absolute value of 9 is 9. Is 9 less than 7 though? No. If you try anything in here, guaranteed, you can replace, it will work. So we found the answer. The next one on that handout says now solve with the help of the formulas there, solve this one. Guys, looks like the next one looks like this. Absolute value of two, subtract three x. Is greater than or equal to one. If I can solve that, not sketch it, that's too much effort right now. Now, which of these two rules in green doesn't satisfy? Looks like this one. Let's see, greater than symbol. So I need to use this conclusion. Now, can anyone see the conclusion in green? U is less than negative A, or U is greater than A. Tell me what that in the green would look like when I apply it here on this particular problem. Someone give me an idea. Go for it.
All of the other sides should be like,
Say it again.
well, all the sides should be like greater than or equal to.
Are you saying two subtract three x? Right here, I want this. Says right here, U is less than negative A. So what would that U is less than negative A translate into? That's the rule followed.
That's the,
On mine, is this my U right here, inside here? Is that the U we're talking about? So it's two subtract three x.
that's the.
Is less than, was it a less than, guys, back on the green? Less than what? And I think it says, back on the green, it says less than, where am I? Negative A. So what does that look like in my case? Less than what? Negative one, yes or no? The truth? And then there's another case here, or, the other case says, now consider this, U is greater than A. Guys, if I match things up, U is two subtract three x is greater than A, and A is what? Did we translate that correctly?
What about the equal sign?
Hang on. Right now, did we translate that correctly or not? He was giving me something else, and I didn't quite understand what he was doing there. Are we okay now with this though? Guys, did we translate it? And I do see the equals mark, I know what Bert's concerned about. But from over there in the green, are we okay? She says, Professor, also, this one did throw in an equals mark. So let's do this. Absolutely. Now, is that translated correctly? If I follow the rule over here. Now solve each one. If I solve the first one, guys, here goes. This is way back in middle school. Negative 3x is less than or equal to a negative 3. Divide both sides by negative 3, reverse my symbol. X is greater than or equal to 1. And we're going to solve the second one here. Let's solve this negative 3x. Let's move that 2 over by subtracting. I think you end up with a negative 1. Divide by negative 3, guys, be careful. X is less than or equal to, symbol reverses, 1/3. Did we do that correctly? Now, I did it quickly. We agree, are those numbers correct? I did it quickly. Now, if I ask you on the quiz, express that in interval notation. When I say x is greater than or equal to 1, I say now express it in interval notation. I hope you would say bracket, I hope, 1 through infinity, Professor. Union, or there, x is less than or equal to 1/3, interval notation, I hope, is negative infinity up to 1/3. Let's put a bracket on that. And see if you guys would agree, does that look like that in interval notation? Yes or no? And it's solved. No problem. Now, I don't know whether I had this one on the handout. I just thought of something I should point out now. Letter C. I want this one. I want to solve absolute value of x is greater than negative 4. What's the first response every semester you think I get? What do you think I'd get for a response here? Anybody shocked? But what response might you be thinking of right now if you see absolute value of x is greater than -4, what do most students quickly say, Professor, what about this? What can I say? Anyone? Absolute value of x is greater than -4. Anyone have a possibility?
Can be any number after.
Vernon says it can be anything.
After 0.
Are you telling me it's negative infinity through positive infinity? Is that what you're telling me the answer is? It's all real numbers? Vernon.
From your
Is
share.
it? Now, she's thinking, Professor, I think it's all real numbers, but many students, as soon as they see a negative attached somehow with an absolute value, they say, hold on, Professor, isn't that no solution? I think you showed one of your professor, if I'm not mistaken, I'm trying to find it, where I think, oh, here it is. You said no solution. Now, why would Vernon say, hold on, Professor, I think this one is, not only it is, it's not no solution, it's everything. A negative infinity through positive infinity. Why? Someone's gonna give me a rationale. Verna has the answer. Can anyone tell me, can anyone justify what she said? Why, you want to say, Professor, there's an answer. There's quite a few answers. It's everything. You may replace x by any number you wish. And you'll satisfy this inequality. Why?
Absolute value will always be.
The absolute value is always understood to be what type of a number?
negative.
Positive or zero, right? Is every positive number in the universe, and let's include 0 also, will they be greater than, in value, greater than -4, guaranteed? That's the answer. If you go back to my graph, here's my V-shaped graph. This is absolute value. Michael, if you put -4 on here, just for a little comparison, -4 is down here. I think I had -4 over there, didn't I? Okay, -4 is down here. And the question is, in terms of a graph, when is my blue graph, my V-shaped graph, above -4? Is it always going to be above -4? Is my blue-shaped graph, the V-shaped graph, always going to be above -4? That's another rationale. Everything works. It's always true. If I did this though, Verna, thank you. If I did this one, before I move any further, let me just put along with this. If absolute value was written like this, absolute value of x is less than -4. Now what's the answer? No solution. No solution. It's written like this. You guys be very careful when these are presented to you. Think about what's going on here. I've got letter D. Go back to my handout though, because I've got a few more to work out here before we do something else. And that is beautiful, beautiful, beautiful. I'm not going to do all these guys. Here we go. A letter D. Please tell me on your handout, is letter D missing the absolute value bars? Letter D in the examples. Well, I put those straight lines, the bars, around 5, subtract 2x over 9, and just notice that. Two straight bars were missing there. Now, the one I want to finish up with, though, is this one. Here we go. Absolute value of x squared plus 2x is less than 15. Looks like that. Now, I'm going to close down. Now, it comes down to now, one of these. One of these two forms to get started. I see what, less than simple over there, I think it is. So it's a less than simple. I'm going to use rule number 1, which is one of the easiest to use, which says, quickly, Professor, write this as, drop the bars there, drop the two straight bars there, and write this as -15, less than this, less than 15. If I use rule number 1, is that what it means? Now you got to solve that. Any ideas how to solve this, my last problem? Is it as easily solved as this one was?
No.
Was it as easily solved as this nice little problem way back over here? No. But it can be solved. Any ideas?
We can do left first and right first.
Come again, brother.
Left side first, the negative 15, less than,
Oh, I see what you're saying. You're saying, Professor, this is so strange, it looks so strange. Maybe I should split them up and first consider maybe 15 is less than this. No problem.
and a factor.
And, there you go, just hold on, Professor, and the other part split up there is this one, x squared plus 2x is less than 15. Guys, I split up the one right above there into those two parts. Is that what those two parts are saying? Did I split them up correctly? This right here is split up, looks like this is the red and then this is the blue. Two problems in one, they're combined. That's why I solve each one. Guys, to try to solve the first one, I'm gonna move the 15 over in the red. And have 0 is less than this. X squared plus 2x plus 15. Is that true? I was hoping, well, I'm looking at it, I was hoping it would factor. I don't think it factors.
We don't have
Does it factor? I was hoping it would factor.
all real numbers.
Okay, now, it says 0 is less than this. I thought maybe it would factor. It doesn't factor, does it, guys? If a quadratic does not factor, what might you try to do to solve for x, if you can? Use quadratic formula? Please tell me what's gonna happen if I attempt to use the quadratic formula on this quadratic, which is not factoring for me, I wish it did. This by quadratic formula says what? -2 plus minus square root of, b squared is 4, subtract 4 times a1, c is 15, I think I see an issue. All over 2. Guys, if I look at that correctly there, is that 4 subtract 60? Which is what, negative? Underneath the square root? So this thing's making no sense. I'm going to imaginary numbers. So we'll just leave that out. Now the blue one, maybe the blue one will work out better for me. Let's move that 15 over and look at this. I hope it works out better. That can now be written like that. Which, thank goodness, will factor into, I think, x plus 5, x subtract 3, less than 0. Is that true? Now, can someone tell me why the red, you place this on my handout, how are you going to finish this thing up and get an answer? Because the blue one looks like it's going to work. How would you finish it up? Now, I had a purpose of putting that on there. And I'll tell you, we've done it in this class before. How am I going to finish this up? At this moment, we have this.
You have to be one negative one positive.
Something else. I'm looking for, 2 key words that we've used over and over and over in this class. I probably mentioned those 2 key words the first night I saw you. Well, what is it that we've used over and over and over that might be applied here to finish this thing up? Oh, I heard somebody say sign analysis. I'm back to sign analysis to finish this thing up. By the way, guys, on the sign analysis, yeah, we go to a number line. We place, in this case, my critical numbers. If I split these up and solve them, I think it's -5 and a +3 here. And it looks like in this case they are to be open. And then you know how sign analysis works, but since it's been a while, you are to test. At your choice, test something and see what happens here. Guys, to the left of -5, we'll try maybe a -10. In between, I'm gonna try 0, nice. And out to the right of 3, I'm gonna try 4. And let's see what happens with sign analysis. A negative 10, put in here. A negative 10 plus 5, of course, will give me a negative. A negative 10 subtract 3 will give me a negative 13, and that would give me a positive altogether, if I made no mistake. In between, I'm testing 0, 0 plus 5, of course, is a positive. Sign analysis. 0 subtract 3 is a negative. Altogether, negative. Out to the right of 3, I'm trying 4 myself. 4 plus 5, of course, is 9. And 4 subtract 3 is a 1. Both positive, that's a positive. Now, can anyone tell me, based on what you see up here as sign analysis, what's the final answer, final result of this? It's negative in between what? Negative 5 and 3. What's all that work? There's the solution to this. Numbers got between negative 5 and 3. Didn't make sense. Didn't make sense. Now, before I leave it, and that sort of closes that section down. Before I leave it, guys, if you get outside here, it's not gonna work. Even if you use negative 5, back here, it's not gonna work. Suppose I replace x with a negative 5 real quickly. Just put a little check here. That'd be a 25 subtract 10. I think. 25 subtract 10 is what, 15? Absolute value of 15 is what? 15? Why can I not even accept negative 5? Does it check? No, I'm gonna get a 15 here. Is 15 less than 15? No. There's no bracket on this, so that number there at the beginning was not going to work. Anything in between should work. So you could actually test the numbers in between, negative 5 and a positive 3. Back here, just for a little check, and they should work. Anything outside, it's not going to work. That took some effort here to get the answer. How's that look for absolute value? You have only 2 rules to follow. Here. So I have 2 rules to follow. And you follow the rules, solve the equation, or solve the inequalities. You got it. How could you go wrong? Well, I think you could go wrong. Now, let me check my time here. Mark, Anna, we've done a good job tonight. A little recap. I did what? 1 word problem, I think. Just 1 word problem, the SMC fencing type problem, which was some big numbers. We did the absolute values. Remind me, guys, what else did we do? Did we do where the graph is given to us and you have to name the graph? Write the equation of the graph with some points on the graph. And that can be a little tricky also, but you gotta be careful with that. Okay, vertex and so forth. I think basically that's all we've done. So I feel good about moving into chapter 3. I see I have a few minutes. I use all my time. Unless you guys want to come in tomorrow. Oh, after that little laugh there. Michael said, I don't think so. Okay. Now, you need to consider that I'll be teaching during summer. Would you like to take this class during summer? Some students say, Professor, are you telling me we're in summer? You're going to do 16 weeks of work, Professor, in 6? Yes. How many hours per day? 3. Plus the little session I have on the side in room 106. Oh, I'm looking forward to it. I don't know whether the students are looking forward to it. 5 days a week. 5 days a week. Anna, Park, they were with me during winter. Same thing. And those students are now telling me they're doing well in calculus. They're now in Math 7. I said, it paid off. It was hard, Professor. You did 6, but we did it. And it paid off. Okay? At least you guys have 16 weeks to get all this done. Guys, I'm gonna leave this, I'm not gonna erase anything right yet. Any concerns about the routine here? The V-shaped graph, the absolute value graph, and all that business? To do? Anything at all to ask about? Just a couple rules to follow here. Now, here's what I want. You said, Professor, the quiz is on Wednesday. Could you be more specific and tell me what am I to expect on this quiz number 3, I think it is? What am I to expect? And it's real short. Right now, I have 2 problems, 5 points each. For most students, probably 20 minutes, probably could be 30 minutes. What are we to expect on this quiz? Guys, I am going to, you saw it tonight, I am going to have a graph of a parabola, like I started class out with. I'll have the graph drawn for you and ask you to write the equation. So there's some points on the parabola. Write the equation of the parabola as we did earlier. That's problem number 1. What do you think problem number 2 might be? What do you think I could ask? It's not really too hard. Maybe for problem number 2. Should I do a word problem? Would you guys want a word problem now, or you want to just wait until the, maybe the next quiz? Or would you prefer to do a word problem on Wednesday?
Wednesday.
Oh, you want Wednesday? Okay, so you want a graph.
If it's the same as.
So you want a graph for sure. We'll do a graph for sure. Parabola drawn for you, and you write the equation of the parabola. That's one question. Second question, I'm just gonna give you guys, give me an option. Did you wanna do an SMC fencing type problem along Pico, or you wanna jump across Pico and go somewhere else? What do you wanna do? A word problem? Using negative b over 2a? Okay, let's do that. I see head shaking. Okay. Okay, so what's gonna be then? Okay, so we'll need then a graph. We have to write the equation for the graph, and then 1 word problem. Okay, and right now it looks like it might be an SMC type again to look at whether we have the fencing at the maximum area. Of course, I'll be available on Wednesday at 4 o'clock to work out anything you want to see. Park, Anna will be available if you guys need some added practice. Now that's what the quiz will be on. Now, the first time I see up here, here we go. I'm going to get started with this. All this is beautiful. No problem with this. Parabolas, V-shaped graph. No problem. Now, this chapter 3, which I will not have much time here, I just want to get some input from you on this. Now, this is introduction to chapter 3. Now, if I get into chapter 3, it's going to really take off. Guys, it's going to be involving this. Polynomial functions. Now, I have just a little time left. Polynomial functions. When you were back in middle school, they had special names for what they identify as polynomial functions. It depended on whether the polynomial function had 1 term, 2 terms, and they usually go up to 3 terms. But they could really go to 10. Because you want to remember a specific name given to a function that contains only 1 term. Polynomial. Does anyone remember the specific term they used that they gave you 2 terms? Binomial. 3 terms. Trinomial. So, like, brief introduction tonight to chapter 3. Now, those are the 3 basic ones. Now, could we have 4 terms? You will have 4 terms in here. 5 terms? Could I have 10 terms? Of course I could have 10 terms. 20 terms. And all these are classified as polynomials. all I'm gonna do tonight is, I'm gonna give you a polynomial function. Let me keep this one brief. X cubed subtract 4x. That's a binomial. There's only two terms. I'd like to, in the little time we have here, I'd like to sketch it. Now, can I use negative b over 2a and complete the square as we've done on the others? No, this is not a quadratic. I can't use that business. This is not a quadratic, this is a cubic. So I'd like to graph it. Now, I need some input as we close down tonight. Does anyone have a suggestion on, all of a sudden you're asked at UCLA to graph this? I can factor, which might help me, okay? So she said, Professor, can you rewrite this as f of x is equal to, Berna, x, take out a common factor of x, you want me to do this? Thank you. Another factoring, difference of squares. He says, no problem. Beautiful. Perfect. I don't have the graph yet though. And I'm guaranteed the graph is not going to be a parabola. I'm guaranteed it's not going to be a straight line. It's not going to be a circle. So I'd like to know, what does a polynomial function, Professor, when you get back into this on Wednesday, what does it look like? Now, close this down tonight, guys. I know you're a little tired from all this work we've done. Anyone take Berna's suggestion where she says factor, which I did? Anyone take it from there and tell me what might be wise to do to see what this graph is going to look like? She gave me a good start. Any ideas? Go for it.
Isn't it a paired function of x?
Okay, beautiful. Hang on, just one second. I love that, love that, love that. He's telling me, Professor, the first thing I noticed, even when you copied the problem down, was x cubed. And x cubed was one of the parent graphs. That's on the handout I gave you guys. So it has something to do, maybe, Professor, with x cubed. It does. Okay, you want to tell me anything else that maybe I could use in an attempt to see what this graph looks like and close down tonight and be ready for you on Wednesday? And she's factored it for me. By the way, if I do this, guys, if I should set this equal to 0 and do what she did for us, actually solve this, you'll get a 2 here, of course. You're going to get a negative 2 here. Anyone tell me what are those in the green there I just solved representing? Those are the x-intercepts. So I know right now 0, 2, negative 2 are on this grid as x-intercepts. She's exactly right. Beautiful. X-intercepts. No problem. Now, if I should ask you, since I mentioned x-intercepts, if I say, where's the y-intercept? I say, wait, Professor, I know how to find a y-intercept. That's easier to find. You find f of 0. In other words, you go back to the original function, replace all the x's by 0. It's not exciting here because it's 0. That says my y-intercept, which common sense tells me, of course it is. It says the origin, 0, 0. That's also my y-intercept, x-intercept. I don't have, so I just connect those 3 points and then close down tonight, and that's my graph. You know you're not going to do that. I bet some students do that. They'll just take a ruler or whatever and just say, connect those, and there's the graph. No students didn't quite make it to math 7, but they did that. It's connected. No. Anyone tell me, before we close down here, what might be wise that we've done in this class before? Finish this up. Yeah, I think you're gonna like it.
Plug in -1, 1, 3, -3.
Okay, and what might I do? Hang on now, I got you. I think I'm here now, Professor, you had better examine each one of these intervals. Something like sign analysis. Now watch what's going to happen. Out to the left of -2, it's your choice. I'm gonna try -4. In between, I'm gonna try -1. In between here, I'm gonna try 1. Out to the right of 2, I'm gonna try 6. Much like sign analysis. I think that's what we had in mind. Okay. Now, guys, we'll test -4. You say, Professor, where are you gonna put it? I'm gonna put it here in the factored form that Verna gave me. I'm gonna replace x with a -4 here in that factored version. So replace x by -4, it becomes a negative. -4 subtract 2 is a -6. And in her factored form, -4 plus 2 is a -2. All that would give me altogether what? Is that a negative? Did I put the -4 in there correctly, guys? -4, -6, -2? There's a negative times a negative times a negative, which gives me, much like sign analysis, a negative. Can anyone tell me what does that mean on the grid, not on the number line that we're so accustomed to for sign analysis? What is that negative sign coming out to be a negative? Tell me about my graph.
It's coming from.
It's below the x-axis. Out there in that interval, to the left of -2, it's below. What does it look like? I don't know. I know it's not gonna be a straight line. So I am gonna make it a curve, something like this. But it's below. Out of that interval. Now, what's gonna happen in between these two? Well, I'm testing -1. Let's take -1 back to her form, which I like, the factored form, which is much easier. Replace all those x's by -1, guys, and get a negative. I'll put it right here. -1 subtract 2, negative. -1 plus 2, positive. I'll do that quickly. If that's true, all that came out to be a positive. Please tell me, what does that indicate about the graph caught between these two, since I got a positive? It's above. So I gotta lift the graph above here. Now, how far up it goes, I don't know, you don't know. That's gotta come back and pick up 0. But in that interval, it's above. Now, I'm testing next 1. Okay, in her form, of course, replace x by 1, that's a positive. 1 subtract 2, negative. 1 plus 2, positive. And looks like altogether, if I have no mistake, it's negative. Which tells me what? Is it down below? This way. Okay, so guys, if I'm dropping down below, and where's my interval here? I'm testing between, where was I testing here? Is it coming down here below? Again, I'm checking here, see if it makes some sense. How far below? I don't know, but it's gotta be below. Must it eventually turn and come back? Yes or no? It's gonna be below. But must it somewhere down here eventually come back up and pick up that 2?
Yes.
Gotcha, but it's below. Out to the right of 2, I'm trying 6. So I replace all these x's by 6, guys, all the way across. It's gonna be a positive all the way across. Which gives me a positive, which says out here, it better be above the x-axis. That is a pretty good sketch. Even though it's a rough sketch, of what this right here, this little simple binomial, what it looks like as a graph. Now, before we close down, is there a local max somewhere on this graph, even though it's a rough sketch? Do you think there is a point I could identify as a local max? Looks like there's one right here somewhere. You'll be able to find that in calculus. I can't show you. Is there also a local min on this graph somewhere? Looks like it's right here somewhere. I can't find it, not pre-calc. Calculus, you can find it. You can find precisely where that local max and local min is. Now here's to close down. Wow, nice, nice, nice. My student was telling me. He says, Professor, the first thing I noticed before you start to work, that the first term was x cubed. From my mind, the first thing I saw there, Professor, was x cubed. And I remember from previous work that x cubed graph looks something like this. Is that somehow, is that the shape of the x cubed, this basic panic graph x cubed? Please tell me, before we close down, please tell me. This is x cubed. Why did I graph it? My student told me, that's the first thing he saw was x cubed the first term. Does the purple and the green, are they related? Somehow. Now, can anyone tell me the relationship before we close down? What's the relationship between the green graph and the purple graph? Are they behaving the same somewhere?
Positive negative.
Let me do it again.
It's coming from negative.
Okay, are you telling me out here, this was one up? The purple was one up? Was also the green one up? So out here on this end, are they behaving the same way? Down here, the purple's dropping down to negative infinity. Is my green one, which is the graph of x cubed, is that also dropping down to negative infinity? Are they on this end behaving the same way? Now, if I had known that ahead of time, I may save myself some work and get the graph a little bit faster. If I knew how they were behaving out there. Is that true? That's what my students tell me there. Guys, with all that said, we did a good job tonight. I'll start with this on Wednesday. Now, again, the quiz, here we go. The one word problem. I don't think you'll miss it. And what the other, I forgot what the other one was. The graph. The graph of a parabola, you have to write the equation. That's a parabola. You get 10 out of 10 for everything. Okay. Good job. All right. Good job, you guys.